classes are always accessed using the objects, and here this represents the inheritance and that represents the access of adoptee class. Here the participants tells that the classes and objects in the pattern with their responsibilities, means how the participants and what are the participants and what are their responsibility in that. Now you can see these clients, targets, adoptee, adopter are the participants of this class. These are mainly here for to maintain some responsibility to perform the task. As I said, here the target was the participant, client was the participant, adopter and adoptee, and these are the participants and what they are doing, associated works. The target defines the domain specific interface that client uses, and client is the collaboration with the objects conforming to the target interface, and adoptee defines the existing interface that needs to be adopting. The adoptee is the interface between adopter and the client, and adopter adopts the interfaces of adoptee to the target interface. It clearly tells what the participants are doing in this particular pattern. And in the representation of design pattern already discussed, the certain headings have to be explained and discussed. And we already came across certain things, and now it's time to see the collaboration. Collaboration, how participants collaborate and how they have to carry out the responsibility that has already been assigned. Clients call the operations on adopter instances. In turn, the adopter calls adoptee operations that carry out the request. Here, adopter instances are created and the adopter calls the adoptee to carry out certain requests. This is the collaboration that is being carried out in the design pattern, that is adopter design pattern. And in the consequences, classes and objects, adopters have different trade-offs. Even classes perform certain tasks and objects perform certain tasks. First, let us see what class adopter does. And the class adopter adopts the adoptee to target by committing to concrete adoptee. As a consequence, as a class adopter won't work when we want to adopt a class and all its subclasses. Here you can see when it won't work, the adopter class and its subclasses will commit the concrete classes. Here we know the concrete class that has the implementation of its own class, the concrete class. Here the adopter uses the concrete classes and its subclasses, and our class adopter lets the adopter override some of the adoptive behaviors. Even as it is being inherited and used and they are interconnected, adopter overrides the adoptee's behavior, and since adopter is a subclass of the adoptee. If it is not a subclass, this would not be able to do. As it's a subclasses, it is the adoptees, it overrides the behavior. And adopter class introduces only one object and no additional pointer indirection is needed to get the adoptee. Only an object introduces only one object, and it is enough to do such tasks, and no additional pointers have been included in this. And we came across the class, how a class adapter works, and it's time to see how object adapter works. An object adapter lets a single adapter work with the many adoptees, that is the adapter itself or its subclasses, or there may be a subclass, there may not be any subclasses. The adapter can also add functionality to adoptees. These adapters have an ability to add functionality to all its adoptees at a single throw. And an object adapter makes it harder to override the adoptive behavior. These objects not only being easy to override, sometimes it makes harder to override the adoptee's behavior. It will require the subclassing of adoptee and making adopter to have a subclasses rather than adopter itself. It requires to have some adopter subclasses interfaces to refer to the adoptee's behavior. Next comes after the collaboration and collaboration, we have to know how these have been implemented, how these we know what are the characteristics and how these design pattern works. After knowing this, we have to implement it to use them. These implementation are generally of three approaches. These patterns have three approaches of implementation: using abstract operations, using delegation objects, and parameterized adapters. We will go through one by one this implementation and how it is implemented. tree display class and director tree display, and it is being inherited. You know, this is the in a UML diagram. It represents the inheritance, and this class is the parent class, and that is the child class, and it is being inherited and used accordingly. Let us see how these implementation is done. Using abstract operation defines the corresponding adapter operations to narrow the adoptee to the tree display class. We have seen at the top there was a tree display class, and subclasses must implement the abstract operation and adopt the hierarchical structure object. You know, in the inheritance, the inherited characteristics from the parent class, the child will be having all the characteristics of parent class, and that can be modified only in the child class. You can use those operations in the tree display which is being implemented in the child class. Subclasses must implement the abstract operation and adopt the hierarchical structured objects. You can create the objects of those. For example, directory tree display subclasses will be implemented in the operation by accessing the directory structure. You can see here the directory files have been also used in the file system entity, that is the adoptee class, and here the tree display is inherited. Directory tree display is inherited from tree display, and it is even used in the directory display, that is here file system entity. It is the adoptee class here. You already know what is adapter and adoptee in the previous presentation. And the second type of implementation is using delegate objects. We have seen abstract class implementation. Now it is using delegation object. In this approach, tree display forwards request for accessing the hierarchical structure to delegate objects. Here tree display forwards the request. It was inherited. Here the tree display forwards the request for accessing the hierarchical structure using delegate objects. Tree display can use different adoption strategy by substituting a different delegate. We can see using an example. Suppose there exists a directory browser that uses a tree display. Directory browser might make a good delegate for adopting tree display to the hierarchical structure. Directory structure. The directory was created, and these directory browsers uses the tree display, and these browsers might make a good delegate objects in the by adopting tree display to the hierarchical directory structure. In dynamical type languages like the dynamically typed objects are Smalltalk and Objective-C. This approach only requires an interface for registering the delegate with the adapter. The tree display simply forwards the request to the delegate objects. Here, as we are having a delegate, we can simply forward the request, and that will carry on the process further. We came across the dynamically typed language like Objective-C and Smalltalk. In statistically typed language like C++, it requires the explicitly interface definition for delegate. It was not required. We can specify such interfaces by putting the narrow interface for tree display requires into the abstract tree accessories delegate classes. And then we can mix this interface in a delegate choice. And in the single inheritance, you can use the directory browser, and no existing parent class is required. And mixing of these classes together can also be performed to achieve this task. Same thing is explained here. Whatever I have said before, it is having a file directory, and this is here is the delegate is used, and this is tree display class. And it is carrying the request. This is a directory browser which I have said in the starting, and this is a tree access delegation. This is a target, and this is the client. The client is reaching to the target using delegate objects. Coming to the third type of implementation, that is parameterized adapter. We came across abstract and next it comes the delegate objects, and now it's for parameterized adapters. Usual way to support pluggable adapters is to parameterize the adapter to one or more blocks of adapters. The block construct supports the adoption without subclassing. Here subclassing is not required, and a block can adopt a request, and adapter can store a block for an individual request. It will be storing an individual request in each block, and it carries the request along with it. Here you can see this is example to create tree display for or a directory hierarchy. This is a syntactical representation. This is how it is an object, how the parameterized nodes are created. If you are building an interface adoption into a class, this approach offers the convenient alternative for subclassing. Here, subclassing of nodes is occurring. Get subdirectory, create graphic node, and here you can see get children block. It's a syntactical code word or how you can say the keyword for accessing and subclassing the nodes in the parameterized approach. Here is a simple code representing the parameterized approach. Here the class, you know the syntax, here the class opening and here the class closes. The class name is shape and here it is a public access specifier, and shape is a function, virtual void bounding box, and a bottom left of point type and top right of point type is created, and this is of this is the class, and here it is of constant type, and virtual manipulator, create a manipulator. These all are the predefined functions that are being used in the class shape, and this ends the class shape. And class text view, here you can see text view function is the get origin. Get origin has the two parameters, that is chord x and chord y. Here you can see parameters are used, void get extent, it is having a width and height as its parameters, and virtual bool is of is empty, which are is empty returns a boolean data, that is true or false, that will be constant. And this is the end of the class text view. We came across the implementation, and already these implementations have been implemented, and there are some known uses that are already being carried out, and these are already in the existence. That is a motivation examples of EPP draw, and here it is a draw reuse. EP++ draw reuses the classes for text editing. It's already being used in the text editing platforms like using text shape and adapter classes, and here you can see interleaves 2.6 are also being implemented using these technology in a graphical manner, that is for graphical appearances, and are therefore these are incompatible with embedded and structural graphic object, and it is having some drawbacks even along with it. And each pattern will be somewhat similar to the other patterns that are already being existed. These are already known patterns using adapter patterns, that is bridge, decorator, and proxy. And bridge, in the further concepts of this module, we'll come across all of these. In a bridge, there are similar objects, adapter and different intenters, and these are independently used, and adapter is meant to change the interface of the existing objects, and decorator enhances the objects by changing the existing characteristics of it, and proxy defines the respective and surrogate for another object, does not change its interfaces. Now after the adapter, this is the these all things have to be till now whatever discussed. When the question is asked related to the design patterns, adapter patterns, so we have to write till here everything along with the headings and with explanation, along with the class diagrams, that is UML diagrams. Now coming to the bridge pattern, after adapter pattern, this is the second type of pattern in this module, that is bridge pattern. Has been written in the adapter patterns, and we know what to write in the pattern name and classification. Pattern name is it is a bridge pattern. We know the pattern name. as we know, the motivation, in motivation part, we have to write some illustrative examples of this design pattern. And we know this design pattern is bridge pattern, and an abstraction can have several possible implementation, and it can have a defined interfaces, and this approach is not flexible always. It depends upon the situation and scenarios or the way you implement. This is not flexible always, and inheritance binds an implementation of abstraction permanently, difficult to modify. Whenever the inheritance occurs, here the difficulty in modification occurs, and reuse and abstraction and implementations are independent here. And we know the motivation will write whatever the things that can be written in a motivation, and we have to give an illustration. So hence here is the illustration. Consider the implementation of a portable window abstraction. We know the window abstraction, X window, PM window, and XPP window, and loop window. In this abstraction should enable us to write the application that work both in the X window system and IBM's presentation manager. So we have to that window we want a particular window is there, and we want that particular window to work in both the scenarios, that is X window and PM window. Using inheritance, we could define an abstract class window and subclass X window and PM window that implement the window interfaces to different platforms. We can, using the inheritance and abstraction, we can make that window to work in both the scenarios by making subclasses. As you know, every technology implemented will be having one or the other drawbacks. This bridge pattern is having this two drawbacks, which are further overcome in the further concepts in this module. I'll conclude by telling the drawbacks of this pattern. It is inconvenient to extend the window abstraction to cover different kinds of windows on new platforms. As you know, we were having two windows. We wanted that two windows to be implemented in the main window, but it becomes difficult to implement in different platforms or new platforms that are being implemented. Imagine icon window subclass the window that specializes the window abstraction for icons. These icons and all will be difficult. To support the icon windows for both platforms, we have to implement two new classes. We were not having the icon facility, but when we need that, we have to again create two new subclasses, X icon and PM icon. For X window, have to create a separate icon class, subclass, and for PM icons, we have to create again a subclass. That is a drawback. We have a double task even though we have combined the windows. It makes a client code platform dependent, and whenever the client creates a window, an object will be created and in a concrete class that has a specific implementation. Here again the client code platform is dependent. A technology have to be in such a manner that dependency is less and user can use it even properly and more independently. But here the client is code platform dependent, the platform dependent. So these are the two drawbacks that have been in this bridge pattern. These two drawbacks are being overcome and being designed and implemented in such a way that is being overcome and it can be used properly. This was my presentation till now. Thank you.